Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Welcome back to the Cloudcast. I'm your host, Brian Gracely, and today we're going to dive into a topic that is probably the number one thing that we get when people send us feedback and they send us requests for, would you please do a show about this? And the challenge has always been that, the request is essentially, can you guys, you oftentimes talk about things that are kind of on the bleeding edge and things that are brand new, but so much of what our audience is oftentimes working on are things that are, kind of established in the business, so applications that people may call legacy or heritage, but in essence, they are oftentimes the most critical applications to the business. But at the same time, they've been around for a while, right? The business has been established. It may have been built on some technologies that was modern at the time, but may not be able to expand the way it wants to. And so we've always struggled to a certain extent as to how to best cover those shows, how to best cover those topics, because it always felt like it was a lot of, well, it depends, or it's a lot of, well, there's a consulting group that might come in and, kind of tell us stuff, but it wasn't a repeatable thing. And today we're really excited because we get a chance to talk about this in a way that feels like it is bringing a modern approach to something that's, kind of top of mind for a lot of businesses, but it hasn't necessarily been something that hopefully was repeatable. So really, really excited to have Edward Hieatt, who is Chief Customer Officer for a fairly new startup, a couple years old, Mechanical Orchard. And Edward, welcome to the show. Really great to have you on today.
Thank you. Very pleased to be here.
So we're super excited to talk about this. Before we dive into it, give us a little bit of your background, both what you were doing previously, but also what's going on. Kind of give us the high level overview for Mechanical Orchard. What you guys are focused on.
Absolutely, yeah. Well, again, thanks for having me. My background, I began as an engineer. I was a Java coder for about 10 years. But during that time, I met Rob Mee, who was the creator of Pivotal Labs, a consultancy you may have heard of that was all about bringing the techniques of what was then a new thing called Agile development to the masses. And we grew that company, and it became Pivotal, which was a company that added that function of how to build great software to a cloud platform called Pivotal Cloud Foundry, and had some great success with those two things, kind of peanut butter and jelly together in the mid 2015, 16 timeframe. Went public in 18, and then VMware bought it, and I stayed on at VMware and was an executive there the last 4 years. But I'm back with Rob now at this company, Mechanical Orchard. I think the way I best can frame it is that, at Pivotal, we did a lot of enterprise software development activity, right? Whether it was helping to write new applications, get Agile disciplines in place, introduce the lean theory, connect the business and IT, or whether it was to migrate applications to the cloud. And as I think you referenced in the introduction there, even when it's a new application, a greenfield application so-called, it's never really a greenfield application. There's always a ton of legacy that you're dealing with. So in fact, a lot of Pivotal's work was about modernizing or rewriting or exposing certain parts of the legacy, migrating to cloud with various different strategies. But there always was a class of applications that felt like we never really cracked the code, so to speak, which was the, let's say, core business applications at a customer, at a large enterprise usually, which represent kind of the IP of the business they're in, the differentiation in the marketplace. The lending platform at a bank, for example, right?
Right.
Which is never going to be replaced by an off-the-shelf solution. It's going to always be custom code. It tends to be old, right? Especially for companies that are, many generations old. It could be 60 years old, 50 years old, 40 years old, mainframes from the past that have been kind of modified, patched over many, many generations, have no real author. No one really understands the whole thing anymore. Maybe through M&A, there's been a lot of integrations that become unwieldy. And so the systems are actually creaking, right? They may be stable, but they're creaking in terms of their ability to innovate or quickly make fixes and improvements. And are therefore kind of very dangerous to try to modify. It's very risky to modify them. And yet the business pressures to modify them for the sake of innovation or saving cost, moving to cloud, or all the modern needs are more and more acute, right? So the company was founded 2 years ago to address this problem. How is it we're going to finally, as an industry, find a safe, repeatable, reliable way to understand, comprehend those old legacy code bases and rewrite them as modern cloud native code bases such that innovation and cost and everything else can be solved for? It's a hard problem, obviously.
Right. I don't want to say many of the people, but a number of the leadership team at Mechanical Orchard comes from Pivotal Labs, yes. Which we've covered Pivotal for a while on the show. Pivotal Labs actually was in place even, I think, maybe before we were starting the show or just when we were first starting. So we didn't cover that as much. Yes. But you've got people that have background with the Agile Manifesto and extreme programming and essentially, a number of experts who kind of said, hey, the old way you've built software isn't going to work going forward. There's these new approaches. Mm-hmm. I'm really curious what was the thing that led to this sort of new mission that said, these things have been hard to crack. They've been hard to deal with because you said they've got all sorts of, just challenges, right? Everything from written in old code to the person who wrote it's not there anymore to we may not have the source code to, all sorts of things. What made you go that something has changed? Some dynamics in the market have changed such that we now want to go back after that problem space.
Yes. Well, I think it's two things. One, gluttons for punishment, I would say. We like the hard problems.
Sure.
And not that enterprise software development is solved with respect to greenfield, but certainly, these days, the idea of iterative development, using lean techniques to figure out market fit, connecting business with IT, all of that is out there. People are trying to do it all the time. It's not totally novel. So while that's not totally cracked and there's still a lot of work to be done, I think the generations have moved on and that's now kind of what's seen as state of the art. So, box checked, so to speak. This problem, though, of how to take the legacy that's so important to, countries' economies, right? Large institutions, and get it onto a more modern platform in a maintainable way, I don't think is cracked. Witness the fact that a large proportion of banks, I think 92 out of the top 100 banks, have a mainframe in place that's running core banking. Or 70% of the Fortune 2000 have something like a mainframe or something from the 70s or 60s in place running important applications. So that clearly isn't a solved problem. And we like hard engineering problems, right? I think number two, in terms of timing, though, that problem may not be very soluble, period, by any humans alone, right? Mm-hmm. It is a very difficult thing to look at 20 million lines of COBOL and JCL and assembler and integrations from all different systems, data flows and different data sources. People don't really necessarily know how all that code works, what data flows there are, right? That is a very difficult thing to get your head around. And traditional approaches involve a lot of interviews and making plans for plans, and we're trying to get their head around what is this system. We think that there's a futility, so to speak, in just banging your head against the wall forever, and that's why this is a hard thing to solve in the past. But the entrance of some of the AI techniques, especially the large language models, who are able to reason over these very complex existing legacy estates, gave us a real sense that there could be something here to help us, as I said, crack that code. Okay. So it's really those two things coming together. The large remaining unsolved problem, what I call the hard problem of enterprise development, is this legacy, right? Yep. And number two, AI could provide a helpful breakthrough.
Yeah. It's interesting. We sort of went through the last decade of all these startups getting founded, and in many cases, you sort of looked at them and you went, I understand you're introducing new stuff, but I'm not really sure what problem it solves. Yes. And, and consequently we saw many of them, sort of struggle to find market fit. I tell my kids and some of the people I advise all the time, I said that, the best thing you can go after is go find the hardest thing, because typically those are the things that people value the most. And, they're willing to, to spend in various ways to try and fix them. So I appreciate that. I'm curious, when you're dealing with stuff that is a little older, because we've talked a lot on this show about some of the things that are happening to help with developer productivity, to sort of developer assistance. We've seen sort of COBOL to Java tools, whether it's GitHub Copilot, IBM. How much of that is feasible when you don't have the code? I'm sort of curious about that aspect of it, because I could see it if you have access to things and it's just complicated, but how much of it is, sort of trying to piece the puzzle together without pieces of the puzzle? And, what do you typically find, either how much is there or how much are you having to make assumptions just based on patterns that you know?
Yeah. So what we're finding, talking to a variety of types of company with all sorts of diverse history, right, is every situation is definitely unique, right? Sure. And if you look hard enough, you can find some extreme difficult situations, right? Sure. So you do find we've lost the source code. We did a source control migration in the 90s, and we lost this component along the way. You do sometimes find that. I think more frequently you find it is difficult to get access to all the different parts of the code base and documentation and so on.
Right.
Mainframes themselves don't make it easy to get at the code, for example, if it's living inside the mainframe and only there.
Yeah.
But it's more a logistics exercise of discovering where everything is, right? That tends to be the issue. So you can get your arms around quite a lot of information, I would say, and it's rare that it's a complete black box, but that does exist. I think the thing that stands out for us, though, is that, kind of getting to the approach a little bit, most of our conversations in this area, when we talk to customers or even partners or incumbents in the industry, centers around this code translation dynamic, right? And it makes complete sense. As you said, you've got COBOL, you want Java, right? You've got COBOL, you want some language that scales well in the cloud. And so surely the whole point of this then is translation, and how do you automatically translate it, and how do you use Gen AI to do that is the kind of current hype, right? And that is absolutely key to this puzzle. Having said that, what we're finding is if you look at the entire time end to end to take a component on a mainframe, say a batch job, right, written in COBOL, talking to DB2, and translate that entirely to cloud native Java, talking to some Postgres solution in the cloud, right? The time that we're spending actually writing the new code, right, is under 20% of the time. There's a lot of other activities that are going on to make that process safe and repeatable and less risky and sort of deterministic in terms of moving forward step by step. That doesn't get the attention in the conversation that code gen does. It's interesting.
Sure. So I'm curious. I want to kind of dig into how exactly you guys go about doing this. I know when Pivotal Labs was coming along, and even when it kind of came into Pivotal, there was this idea of sort of a pivotal way, right? There was a sort of a defined way of doing things. There was sort of the 12 steps of how you'd build a cloud native application. Is there, I guess, sort of two questions. One, is there like a mechanical way, right? Do you guys have a framework that people would look at or could follow? And then what is happening in whether it's in that 20% of writing the code, but the other part of it to make it as possible?
Yeah, totally. Great. So you're quite right. At Pivotal Labs, which I joined in 2003, there was what we've probably been called in a positive way, I hope, opinionated points of view on how to write software, right? Yep. And that really came from experimenting with a set of disciplines that, on the face of it, sounded perhaps unintuitively possible to pull off. Pair programming, test-driven development, all these things turned up to 10, turned up to 11, some people say. And sort of it can be seen as sort of a zealoty approach, right? Like you're going to do those things full out, and that's the religion and so on. It comes, though, from our experience of seeing just wild success when we attach to disciplines and kind of keep our eye on the ball, so to speak. And you do get kind of this very excited developer base when they've seen what can be done, right? In that case, in software development. And no surprise, we do have a similar kind of point of view on this problem. And it is a different take on the methodology than the traditional approach, which, as I mentioned before, tends to start with code translation, because that's the center of the bullseye, right?
Yeah.
We have the mechanical orchard method. It's 6 steps. And happy to point you, and we could put it in the show notes, at what those really are.
Okay.
But to summarize it, the approach we have is different from the traditional approach in that we actually don't start with the code. We certainly want to look at the code and what documentation exists and talk to SMEs and the rest of it. But because the code bases can be so complicated and impossible to really spelunk around in some cases, as you were describing, we actually don't start with the code. We start with the data flows, right?
Okay.
These systems are working in some way. Typically, they're actually fairly stable, right? Because they've been around forever and they're running the core business. So what we do is we actually look at the flow of data of any type in and out of the subcomponents of the system. So I'm talking about, database reads, database writes, file system reads and writes, queues, emails being sent, anything, right, over any protocol, maybe any packets coming in and any packets going out to a given process. Let's take a batch job in the case of mainframe again. And we record that data manipulation. Right? We record it, and we then reverse engineer by hook or by crook, perhaps using AI, as we mentioned before, to help generate some of that code. But that's not deterministic, right? It can hallucinate, as everyone knows. So it's a manual effort as well.
Sure.
We prove the validity of that rewritten component, not by just saying, hey, the code's equivalent, trust us, the AI said it was, or something, but rather by playing back those same data flows and comparing the output down to the packet with the output of the original component. Once we get some confidence there, we actually put that component into the production environment as a candidate, right? And compare its output to the existing component's output over some time period, right? In the case of a batch job that runs nightly, it might be 3 weeks or 4 weeks or 5 weeks, where you get every day of the week, the first day of the month, etc. And if we can show that it's equivalent, again, down to the packet every single night it runs, right? Or every input to a green screen that's done, every transaction in the system, that gives an amazing degree of confidence in equivalence of the new and the old, right? Okay. Which is, we think, one of the key dimensions for de-risking and giving confidence and overcoming the hurdle of reluctance for the customer, right? So that is a key aspect of the process, and it kind of gets to that different approach that isn't just about code generation. Now, just to finish it off, right, you've then got some components that are new, rewritten, running in concert with components that are old, or the old ones,
right,
at the same time. And here's a good analogy to the Agile concepts. In the Agile methodology, as everyone I'm sure is aware, there's this sense of moving away from a big bang approach into a always building approach. That's what Agile means, right? You're iterating all the time. So rather than building a big spec and putting it live and effectively hoping it works and people like it, you're instead putting something live that you're seeing people like and making it better and better and better. And you have much, much less risk in execution because you're constantly validating as you go. Same idea here. Rather than saying, let's rewrite this whole thing from scratch and put it live and cross our fingers, which is honestly what tends to happen with these big initiatives, which is why they so often fail. Right. We have evidence that about 3/4 actually are considered to have failed in these big migration efforts, which is amazing, right?
Exactly.
Rather than doing that, we're saying let's put a component and then 2 components and so on live and have them work in harmony in what we call the mechanical orchard with the old components. That is a hard thing to do in engineering terms, right?
Sure.
But you can see if we make that hard thing easy and you're then living in this hybrid state, then the risk again comes way down. So it's about proving equivalency, right, of each component beyond a shadow of a doubt. And it's about working incrementally in productionization terms with the old and the new components running together. And that approach massively de-risks the overall initiative and gives newfound confidence and hope to the customer base that we're targeting.
Yeah, it almost feels like, and maybe this is the wrong analogy, but it almost feels like what people are doing with digital twins, in which they're
exactly right.
They're trying to create a synthetic version of it to see if it behaves the way and probably you can manipulate the behavior that way.
That's right.
Okay, well that makes a ton of sense.
Maybe just to mention, I mean, you mentioned digital twin. There are technologies out there that various cloud providers have as well. Not all of that is completely novel to us, right? As you say. What I would say is, just like in the Pivotal Labs case, the Agile stuff was completely out there in books before it even got spun up. We stand we stand behind the discipline around it. So we're actually going to do it. And again, we can get to the AI tooling if you're interested in that. How is it that tooling can make all that less onerous? That's a very hard engineering problem. It takes very smart people a long time, right? How can we make that realistically reproducible, repeatable, and not so expensive?
Yeah. And as you're, and again, I don't want you to necessarily give away any secrets, but as you're modeling these systems, right? So you take a bunch of packet flows, you take a bunch of data flows. Obviously, it sounds like you guys have then sort of built systems that say, look, here's some inputs. Not only understand the inputs, but then go off and sort of write the logic that write the code that would have done this. Is that sort of the big challenge? Yeah.
Exactly. Digital twins are effectively, in our mind, until proven, they are candidates that could be equivalent, written by hook or by crook, right, to replicate the same behavior as the old components, which tends to be business logic and all sorts of other types of code. Right. How to produce that reproduction could be all manual. That works too, right? Sure. By people inspecting the code and asking questions of SMEs and so on. We don't think that the AI industry is at a place where you can push a button and get perfect cloud native code out of the box yet. Right. We've seen proposals by others that say we're going to produce generated Java code from your COBOL. It'll be more lines, hard to understand, probably slower. Right. That isn't the right answer either. So we're working hard on tooling to make that generation phase produce really high quality code with a human oversight to it. It is agentic, but the human's involved, such that the code base is malleable, maintainable by your standard modern developer, test driven, golden path to production, all the rest of it. We're seeing about a 80% lines of code reduction from the old verbose code base, which typically has some dead code paths and duplication and poorly written code in general, just over the generations. So you can do amazing things with AI technology and human oversight to make the code malleable. Because of course, many times the motivation for this effort overall is not just get to cloud or reduce cost. It's also let the business free to be innovative, right? So the ability to go and add functionality, fix bugs, and all of that once you've proven equivalency is often the driving factor. So making the code malleable, well written, contemporary, shall we say, is an important part of the goal.
Right. Yeah. I want to shift gears a little bit. One of the things that and again, I hate to keep making the pivotal equivalent, but I know people are familiar with that. Even just in the agile space, there was a certain amount of sort of cultural big bang or sort of cultural, acceptance that had to happen of like, we're going to do things differently. And some of these are going to feel like things that inherently people are going to go, well, that's strange or weird, or just, it is different, right? And different for a lot of people is hard to deal with. Absolutely. When you're dealing with some of these older systems, it's been well documented. IBM has long said, hey, we're concerned that over time, there won't be enough COBOL developers, and they've been trying to find, younger programmers. And so I imagine you're going to have certain amount of culture just at a technology level, people that know certain things. But when you introduce an older path of the system that probably doesn't change very often, maybe once a year, maybe every couple of years, to something that changes multi times during a calendar year, what are some of the things that you've seen? Because you guys have a number of companies that are in this process or have gone through it. Like, what does that cultural kind of cohabitation look like?
Yes, absolutely right. Yeah, you're quite right. In the Pivotal Labs case, we were often coming in and proposing a way of working that was entirely foreign, right, and unintuitive, like I said, and certainly caused a change in people's day-to-day experience of their job, which can be jarring. Now, I would say that what we always said was, hey, just come under our wing, try it this way for 3 months, and if you hate it, you can stop doing it, right? Sure. And I would say that with a straight face, I can claim that almost every time people found value in it to some extent, right? But certainly that was a superpower, but also could stall adoption of our ways and our method and our platform, because it's hard to propagate that. As you say, it's a change management exercise. I think over the years it became less and less exotic, less and less alien to people. So it's kind of, as I said, it's kind of happened now more and more. At least people have that as their North Star. In this case, we're talking about we're going into departments in IT which tend to have people who've been there many decades, right? Who are running the mainframe, say. I should mention, by the way, it's not just mainframe we're talking about. It's really any legacy. Mainframe is definitely a sweet spot.
Sure. It could be flight control systems. It could be all sorts of stuff.
Exactly. Yeah. We have customers who have big Power Builder code bases, or BASIC from the 80s, or all sorts of interesting stuff. Lotus Notes technology and so on.
Right.
And the goal we have at Mechanical Orchard is less to change the culture of that department. I just don't think it's as effective, right? It's not as realistic. We're talking about leapfrogging here. So our approach is different from the pivotal one. It's not all about enablement or about shifting culture in an existing team. It can be. That's absolutely an offering we can support, because we have the same leadership and ways of going to market and so on as before, and contracting mechanisms and all the rest of it, and people who can kind of transfer through osmosis the culture to others. That's a superpower we still have. But in general, we're saying, look, we'll come in and take this very hardened problem that you have and take it under our own wing, right? That is, we will take on the code translation, we'll take on the proof of equivalency, we will help you with and we'll take responsibility for the hybrid operations of the old and new components as we go, right? Like, let us take it from you, but we're going to produce for you a contemporary, modern, idiomatic code base that either we or you or a third party can then maintain over the long term, right? So we're kind of saying, like, let's take you from the very distant past to the future. And we'll do it all for you, unless you want us to involve you, because we think it's going to take something as dramatic as that to finally get out of this rut, right? Now, again, we can involve customers as much as they want, but that's what we're doing, which is different from pivotal, right? We're just saying, let's do it for you and let's get to the future.
Gotcha. I want to ask you one last question. Obviously, we could go into tons and tons of detail, and as always, we'll sort of refer folks back to the webpage. As you're engaging, you guys have done this a number of times. What's a typical, first couple of steps? How do, because you mentioned you're doing this in parts of the application or parts of services. How do people feel like success looks like, or what have you seen?
Yes.
Enough where people go, okay, that moves, let's move on to the next thing. Or we feel, where does that come? Where do those comfort levels come from?
Very good. Yeah. So as you say, I mean, the typical customer we approach has had a problem for a long time, oftentimes, right? And they may have tried to modernize and had a problem. They may have spent money already. They may have never tried because it seems so risky, and it is so risky, or the ROI never really made sense. Just throw money at the mainframe and let's just kick the can down the road. So typically we have customers who are under some kind of acute pressure to do something about the problem finally, but also who are reticent to take risk because it's just a difficult balance, right? So our approach is to start, as you might guess, start small, chip off a part of the problem, and demonstrate very quickly how effective we can be with modernizing that smaller component, right? So we'll do, kind of a workshop and get our head around the system, propose perhaps which component to start with, but then spend 6 to 8 weeks just going hard at that one component in isolation, showing how the modernization can go, showing the proof of equivalency, etc. Right? That's very important. And we've got to show the customer, like, look, there's a way we can do this. It can be done, right? But it's real work. It's not POC. It's actually doing the first step. The second step is, okay, let's get that in production. It's a second step because getting in production is not just technical, it's also people and approvals and compliance and all the rest of it, right? But that second step is really where we get the most aha moments for customers. It's one thing to rewrite something and show it's the same, but to actually put it in production side by side with the N-1 remaining components, that typically is where the comfort level starts to skyrocket, because they can then see, oh, wow, I see. You've modernized it. You've put it in production. And whether it was as fast as I want or not, we're now living in this hybrid world. And I can imagine turning the crank now, one by one, on these components over time and having a non-disruptive, low-risk way of moving forward. And it's at that point that we tend to, write the longer-term contracts and get into the bigger conversations. So it's kind of those initial 2 steps, right, that we really put our effort towards, and we make affordable for customers and so on, because it takes showing people a ray of light. At the end of the tunnel, where there is a possibility of success here. Watch us do it, right? So we're not in the kind of, let's plan for 6 months, understand the whole system. We're like, let's get going early and have the work inform the plan and show it can be done. Right.
Yeah. And I have to imagine, just at a, psychological level, that when you do it as a big bang, you put this sort of either or question to a customer, like it's going to work or it's not. And you're just kind of, you can do all the ROI numbers, but it comes down to a gut feeling. I have to imagine that first thing that you put in place to them probably is that day is scary, that month is scary. And then you start to live in it, just like if you move to a new city or you go off to whatever, and then you can start to sort of live in it and start to feel like, okay, what, where are my comfort levels? What do I want to do? And it's an interesting path. It feels very natural to anything that we do now that's modern, in which you sort of introduce, but to a world in which everything is either holistic or not. That's got to feel entirely foreign and a nice life jacket, if you will, almost.
It does feel foreign, but I think the notion of putting the candidate component in the production environment and not relying on it until the nightly proof over weeks or months or more is there that the equivalence is the same really helps. It's kind of like moving to the new city, but renting for a 3-month period and seeing if you like it, and then committing to buying a house after that.
Right. Yeah, no, I think that's a great analogy. Well, listen, this has been fantastic. Like I said, it's a topic that we get asked all the time, and we always felt like doing a show about, well, it depends, wouldn't have been terribly valuable to people. So we appreciate you guys having a new and novel approach to this. And then obviously, your team has tremendous amount of background in doing not only new software development, but really sort of change, in organizations. So it's very cool to see you guys, kind of going after this challenging problem. So any last things you'd love for people to kind of, either engage with you guys around, or just sort of things to get out there?
Yeah. Well, again, thanks for the time. As you say, I think this is actually a really fun area of the industry, because there's all sorts of, as I mentioned before, kind of spelunking and looking at old technologies, which geeks like us enjoy, right? What is out there? I've been amazed by just how much is out there that I wasn't as aware of as I thought I was.
Sure.
And to apply the latest kind of technology, AI and the rest of it, and a novel process to solving that old problem is really interesting, right? It's the newest and the oldest of the industry being put together. I'd say, we're very interested in helping people think through their approach to this, especially in the case where it feels scary, it feels full of risk. So getting in touch with us through the website is definitely a way to get started, and we can talk sort of big picture about the strategy with you and how to make this not seem so frightening, how to involve the business, for example. All of that is something we can start with. And I think we're going to link in the podcast notes to some information about sort of more detail of what I've been talking about and what it really looks like to work with us. So
absolutely.
So thank you again. Yeah.
Well, good deal. Well, Edward, thank you so much for the time today. On behalf of myself and Aaron, we appreciate anybody who's willing to sort of educate us on some of these challenging problems. So thank you so much for that. Folks, with that, we're going to wrap it up. Again, we want to thank you, Edward, for his time today. If you have questions, we'll put some things in the show notes as the best way to get in touch. But with that, we want to thank you all for listening to the show. Thanks for telling a friend about the show, helping us grow the community. And with that, we'll wrap it up, and we'll talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.